So now I'll show you the relationships between zeros and coefficients of a polynomial. It is very important, very important. So let us start with the linear polynomial first. Linear polynomial. Linear polynomial is, px is ax plus b. Degree 1, so only 1 0, and that very easily we can find out by equating it to 0, as this will be 0 for, and that will give you x is equal to minus b upon a. That is, for this value of x, the value of the polynomial will be 0, so that obviously this is your 0 of the linear polynomial. So now it is again a convention to express the zeros by Greek alphabets. So like this, alpha, beta, gamma, delta, these will be denoted, it will be used for denoting the zeros. So here only 1 0, so I write it as alpha. So alpha is the 0, only 1 0, so I take it as alpha. Next, for quadratic polynomial, the standard polynomial, as I've shown you, will be like this. That is, the real coefficients are these, a, b, c are the real coefficients. So here you see that this 0 is related with the real coefficient in this way, minus b upon a. So quadratic, so to degree 2, so there will be 2 zeros. So and maximum number 0 will be 2, and we take, let the zeros be alpha and beta. Let the zeros be, the first zero always you take alpha, the second one beta. It is also in the Greek alphabet order. So corresponding to this, it will have a 2 factor corresponding to is 0. There will be a linear factor. So I can write in this way, some constant into corresponding to alpha, x minus alpha is a factor, and corresponding to beta, x minus beta is a factor. Now if you recall the factor theorem that you have studied in 9th class, what was the factor theorem? The factor theorem was, if a is a 0 of a polynomial p of x, then x minus a is a factor of px. Okay, if a is a 0 of the polynomial, then x minus a will be a factor of the polynomial, and vice versa. That is, if x minus a is a factor, then p of a will be 0. All these things you will have done in learned in 9th class. So by factor theorem, actually we can write that corresponding to each 0, I will be getting a linear factor. And since I don't know what is the coefficient is a, so I have taken some arbitrary constant. So this I can write in this way by using factor theorem. Now I'll show you the derivation to get a relationship between the coefficients and zeros. So if I open this, then this will become, using the identity x square minus alpha plus beta into x plus alpha beta. So you know which identity I have used. You have learned in 9th class, that is x plus a into x plus b is equal to x square plus ab into x plus a plus b into x, or let me write down the identity that I have used. X plus a into x plus b is x square plus sum of the constants into x plus product of the constant. This identity is used. This is the very first identity that you learned in 9th class. So this. Now what we'll be doing, now this is equal to this. Now I will be comparing the coefficients of the similar terms. So here the coefficient of x square is a. So here will be equal to coefficient of x square is k. Next, coefficient of x is here b. So b will be equal to coefficient of x here is minus of alpha plus beta. Then third, compare the constant term c is here, and here the constant, sorry, here k will be here because this k is there. So k into alpha beta is the constant. So by comparing the coefficient of the similar terms, I am getting these three things. So now you see, from this what can I write? Alpha plus beta will be, minus will come as b, or b upon minus k from this. And what is k? K is a. So I can write this minus is there, b upon e. So sum of the, this is, I got the first relation that alpha plus beta is minus b by a. Then from this what I get? Product of the zeros, alpha beta is c by k, that means c by a. So simply by comparing the terms, I can get the relationships. So this is the derivation I have shown you. So let me write down the relationships. So for linear, there is only one zero, that is minus b by a. And then for quadratic, I am getting two relationships. First one is sum of the zeros is minus b upon a, and second relation, alpha beta, product of the zero is c upon a. So I got this for the quadratic. Similarly, for cubic polynomial px, which will be of the standard or general form like this: ax cube plus bx square plus cx plus d. Here, since maximum degree is 3, so maximum number of zeros will be 3. And let us take the zeros as alpha, beta and gamma, 3 zeros. And by the same logic, similar way that I have derived these relationships, that means what will it be actually? K by factor theorem, some constant into corresponding to each zero, I will be getting a factor. So it will be x minus alpha into x minus beta into x minus gamma. So this will be the thing. And if I open this, I will be getting an expression which I can compare with this, and I can get relations like this. Or let me show you this one. If I open this, so this will be equal to k into, let me first find the product of these two, x square minus alpha plus beta into x plus alpha beta, this into the third factor x minus gamma. Okay, then again let me multiply x cube, then let me take the coefficients of this case there, alpha plus beta x into this x square plus this alpha beta into x, then this is gamma. So minus gamma, let me multiply, minus gamma into x square minus plus alpha gamma plus beta gamma into x, and lastly minus alpha beta gamma. So I have multiplied. Now let me rearrange k into x cube. This is an x square and there is another x square. So let me group them. So if I take minus common, alpha plus beta plus gamma into x square, then let me group the this term, x terms, plus x you take common, then alpha beta plus beta gamma plus gamma alpha into x. Then only the constant term is left, that is minus alpha beta gamma. So I can simplify this in this form, and now I am in a position to compare the coefficients. That is, and now I will be comparing these with this. So coefficient of x cube is again here a, and here it is k. So a is equal to be always like this, a is equal to k, and coefficient of x square is b here. So b is equal to k into this. So minus k into alpha plus beta plus gamma. Then coefficient of x is c. Here coefficient of x is this one, k into alpha beta plus beta gamma plus gamma alpha. Then lastly the constant term d is equal to the constant term here, k into minus alpha beta gamma, or I can write minus k into alpha beta gamma. So now I can write the relationships. So from sum of the zeros, first relation, sum of the zeros, here you see b by minus k, k is a, so it is minus b by a. Or if I divide this by this, I can get directly minus b by a. Next relation, this one, sum of the product of the zeros taken 2 at a time. So alpha beta plus beta gamma plus gamma alpha. What is this? C by k. What is k is a? So c by a. C by a. And the third relation, product of the zeros, alpha beta gamma. What is that? D by minus k. That is d by minus a, minus d by a. So these 4 relations I got. So you see, if you now observe the pattern, when 1 0 there is linear, 1 that is a minus b upon a, and when 2 0 that is degree 2 zeros, 2 relations. One is sum of the zeros taken 1 at a time, product of the zeros taken 1 at a time. So these are things. Here when the degree 3, that is cubic polynomial, 3 zeros, so 3 relationships I got. The first one is always sum of the zeros taken 1 at a time, product of the zeros taken 2 at a time, sorry, sum of the product of the zeros taken 2 at a time, and then lastly product of all the zeros. So in this way go, and you see always it is starting with minus b upon a, minus b upon a. First relation is always minus b upon a, minus b upon a, minus b upon a. Second relation is always c upon a, c upon a. And the next in this way. That is what the denominator is always a, that is the coefficient of the highest variable term. And the denominator is increases alphabetically. First one b, then c, then d. And sign also, first one minus, then plus, then minus. So observing this special pattern, now without doing any derivation, I will be able to write the relationship between the zeros and the coefficients of any polynomial of any degree. So let us find out the relationship of zeros and coefficient for biquadratic. First degree is 4. Without deriving, now I will be able to do it. So let me erase this one. So I will be writing biquadratic one. So why biquadratic? Polynomial px will be ax to the power 4 plus bx cube plus cx square plus dx plus e. So the zeros will be, maximum number of zeros will be 4 zeros. So alpha, beta, gamma, and the fourth one I take as delta. So these are Greek alphabet also I have taken in the alphabetic order. So degree 4, so there will be 4 relations. First relation, sum of the zeros taken 1 at a time. This is will be always minus b upon a. Second relation will be sum of the product of the zeros taken 2 at a time. etc. like this. There will be how many terms will be there? 4c2 factorial 4 yes, 6 terms will be there. 6 terms will be there. This relation is not that important, but I am writing there will be 6 terms and it will be C upon A. Then the third relation, I'll write it again. Third relation will be sum of the product of the zeros taken 3 at a time it will be 4, one more, alpha, delta and beta, alpha, delta, gamma, alpha, delta, oh sorry, beta is already there, so it will be alpha, delta, gamma, no, I should not take alpha, should take beta, gamma, beta, delta and alpha. So this will be minus d upon a. You see, minus plus minus, and the fourth relation, product of all the zeros. It was minus, it will be plus, A, B, C, D, it will be E, and this way. So these will be the 4 relationships between coefficients of the and the zeros. So this is the pattern. Always start with minus b upon a, then b, c, d, e. In this way it will go. Denominator is always a, and sign minus plus minus plus. So by the same way, if I can take a polynomial of degree 5, I'll be getting a fourth relationship, and there will be one more zeros, and so the last relation will be f by a. So in this way we can write the relationship between zeros and coefficient, simply following the pattern. Okay, now I will show you the application of the relationship. Why I have learned that this relationship between zeros and coefficients? Because they help us in solving some questions. So I will show you. So question. So one question I'll show you. Say a polynomial is given 6x square minus 3 minus 7x. You have to find the zeros and to verify the relationship. That is very easy. What you have to do to finding the zeros, you have to factorize it first. So first you write in the proper order, 6x square minus 7x minus 3. Factorization by splitting mid-term, you know how to do. You take the product of this coefficient of the highest power and the constant, 6 into 3, 18. And since minus sign, I have to, 6 into 3 is 18. And since there is a minus sign, so I have to break this 18 into 2 factors such that their difference is 7. That is the thing. And if there is plus sign, then what we do, we take the we break them in such a way that the sum of the 2 factors is the middle term. That is the way of splitting the midterm. So since minus sign, so I have to break in such a way. I know if I break in this way 9 into 2, I know difference of 9 and 2 is 7. So this will do. So in this way, write 6x square. Minus is there, so that I take the bigger factor with the minus sign. This is the splitting midterm method. Take 3x common, 2x minus 3, then plus 1, 2x minus 3. 2x minus 3 into 3x plus 1. So I have factorized the given polynomial into 2 factors. So from each factor I will get the value of 0. So when I equate the first one, so when twice x minus 3 is 0, what I am getting the value is 3 by 2. And when 3x plus 1 is 0, I am getting x to be equal to minus 1 by 3. So these values are the zeros. Therefore, the zeros I have taken, so let the zeros be, let the zeros be alpha and beta. That you have to write first. So the first zero, alpha, will be 3 by 2 and the other zero, beta, will be minus 1 by 3. So first of all, I have found the zeros. Now I have to find the coefficients. So comparing this with ax, the standard one, ax square plus bx plus c, the standard one. So comparing with the standard one, a is equal to 6, comparing 6, b is equal to minus 7 and c is equal to minus 3. Comparing, how do you get it? Comparing given polynomial with the standard one. I can find the values of the coefficients. ABC are the coefficients. Now I have to verify the relationships. So two zeros to two relations. The first relation, verification part. Verification. First relation, sum of the zeros has to be minus b by a. So let me find out the sum of the zeros. 3 by 2 minus 1 by 3. So these values I have put. So what is the value? What I have to verify? Verification, let me write down first. Verification of alpha plus beta is equal to minus b by a and alpha beta is c by a. These two I have to verify. So I am doing the first one. So what is this? If I take LCM, now it is the LHS. Now let me take RHS is your minus b by a. Put the values minus, what was b? B is minus 7. Minus 7. And what is a? A is 6. So it is 7 by 6. Same. Therefore, LHS is equal to RHS. Hence verified. Hence verified. In this way you have to write. So the next relation, for the next relation, that is alpha beta is c by a. Left hand side, alpha beta, put the values 3 by 2 into minus 1 by 3. 3 by 2 into minus 1 by 3. Minus half. And RHS c by a. What is c? C is minus 3. Minus 3 and a is 6. So it is minus half. So LHS is equal to RHS. LHS is equal to RHS. Hence verified. So in this way we do the verification. First we find out the zeros, then we find out the values of the coefficients comparing with the standard one. Then in this way we do the verification.